All right, lesson 6.4 is on percent of change. And what that is it's a ratio that compares the change in quantity to the original amount. So the formula that you guys are going to use, the equation, the percent of change equals the change divided by the original. And to find the percent of change, that's why we have to multiply it by 100. Now, the most important part of this formula is how you find change. It is your final amount minus your original amount. All right? It's not the big number goes first and then I subtract. It is the final minus the original. So yes, sometimes your answers are going to be positive and sometimes your answers are going to be negative. So increase or decrease. If the percent is positive, then that means the percent of change is a percent of increase, positive, going up, rising. And then if the percent is negative, the percent of change is a percent of decrease, it's going down. So for this example, find the percent of change from 60 degrees Fahrenheit to 84 degrees Fahrenheit. Then state whether the percent of change is an increase or a decrease. So if you go back to the formula that you just wrote, look in your notes right above you, right? It's the change over the original. So to find the change, it's the final amount. Well, the final amount for the temperature, it went from 60 to 84, so that final amount is 84 degrees, and the original was 60. And that's getting divided by the 60. So I need to take care of this subtraction first. 84 minus 60 would be 24. And then 24 over 60, remember that fraction bar means division. 24 divided by 60 is going to give you 0.4. Now, that is not your answer. Look back at the formula. Look back at what you're being asked. You're trying to find the percent. To find percent, then you need to multiply by 100. Change that decimal to a percent. It is not 4%. It's going to be 40%. And now, because that percent is a positive number, that means it is a percent of increase. Okay? All right, we also need to talk about the percent of error. So what that is it's a measure of the difference between an estimate, prediction, or a measurement and the actual value. So this is the formula. The percent of error equals the measured value minus the actual value. And it is the absolute value symbol there. All right. And then once you have that, you're going to divide it by the actual value. And then you multiply it by 100 to get your percent. So one thing I want you to be aware of is that the amount of error is non-negative when calculating the percent of error. That's why we've got the absolute value there. Alright, so our example here. Alyssa estimates that her school auditorium has 660 seats, and it actually has 750 seats. So what is the percent of error in her estimate? Basically, how far was she off? So what we need to do is we need to subtract. We need to take what she estimated, what she thought, what she measured, which was 660, and subtract the actual value, which is 750. Once we get this, excuse me, we need to divide it by what the actual amount is. Now again, it's the absolute value. There is no negative here. So 660 minus 750 is going to give you negative 90. But again, the absolute value of negative 90, how far away from 0 is 90? It is 90. So what we are actually doing is we're taking 90 divided by 750, which is going to give you 0.12. And then we need to convert that to the percent. That's going to tell us the percent. Again, always multiply by 100. And so you get 12%. Her percent of error was 12%. All right, we are going to do a lot of this using these formulas in class tomorrow, so I will see you then.